This is A2physics A21S. A motorcycle is fitted with a rear view mirror attached to an arm which is bolted to the handlebars. The mirror and arm assembly has a natural frequency of 13 Hz. The motorcyclist is stopped by traffic lights and the engine of the motorcycle is running at 800 revolutions per minute. The handlebars vibrate at the frequency of the engine. Explain why the image of a car which is behind the motorcycle is shaking and hard to see when viewed by the motorcycle. Well, the first thing that you can do there is calculate the frequency of the engine. You know it's running at 800 revolutions in a minute, so that's 800 in 60 seconds, and that gives you 13.3 Hz. Now this is similar to the natural frequency of the mirror, and therefore the mirror vibrates with a maximum amplitude, and it's difficult to see a clear image. So if you get a question where they give you numbers like that, you're always better to do a calculation to back your answer up. And you wouldn't know unless you'd done the calculation that that's true. The traffic lights change to green. The motorcycle accelerates so that the engine is running at 3000 revolutions per minute. Explain how the quality of the image of the car would change, if at all. So again, we'll calculate the frequency. Frequency is 3000 over 60. And that gives you 50 Hz. And this is much larger than the natural frequency. Therefore it vibrates with a much smaller amplitude, and image is much more easy to see. And there's where your 3 marks are going there again. In an attempt to rectify the shaking of the image in A, the motorcyclist put some thick foam between the handlebars and the arm of the mirror assembly. Would adding foam get rid of the shaking of the image? Explain your answer. Well, adding foam will damp the oscillation and absorb some of the energy. So therefore the amplitude of oscillation will be much smaller, and the image clearer. So there's a mark for that and a mark for that.